So once again, welcome to this our today the second duration of the first session. In the first, in fact, I will say second session. In the first session, we have discussed about some fundamentals of the solar photovoltaic, and now we will discuss some advanced things also. But before that, something is left from fundamental also, that how to choose a solar panel. So selecting a right technology depends upon that how much money you want to invest, how much money thing you want to invest. So if you have a handsome amount of money and you want a good efficiency up to 20%, then you can go for a monocrystalline. And the present situation is that the monocrystalline price has reduced drastically, and the difference between polycrystalline and monocrystalline is very less. So you can go for the monocrystalline. However, polycrystalline have an efficiency up to 17%, and the cost is between, as you can see now, it has also reduced. Now it is only 40 rupees per watt. Due to COVID-19 situation, it has increased it from 40 to 45 and 46 like this, but less than monocrystalline. Then thin film cells are no doubt, they are also in the range of the polycrystalline, but the efficiency is very poor. So in India, we generally go for the polycrystalline solar photovoltaic panels. Okay. Then we have to check our ratings also, because nowadays the solar panels up to 500 watts are also available. Okay, so if you want to install a 1 kilowatt solar power plant at your home, then you have to go for two 500-watt panels only. Now if you go for 250-watt panels, then you have to install four, so more area will be occupied with. So it depends upon many things, many factors, that how much panels and which type of panels you can use it. Now next is the type of solar photovoltaic system. There are three types of systems are being there used. The standalone system. Okay, now in this standalone system, we can simply understand that whatever the solar photovoltaics is being generated is being not connected to the grid, but it is being used in a sole form. Sole form in the sense that uh, the energy generated by the solar panel will be directly used. Now there is one problem is there. It is a very costly system. Standalone system is a very costly system, because I have already told you that the solar photovoltaics is generating DC supply. Okay, and that DC is also of which type of nature? Fluctuating DC, because your solar insolation are not constant. During the sunrise, they are very low insolation are there, but as the sun moves from east to the south, the solar insolation increases, and as it moves from the from south to west, again it decreases. So there's a fluctuating insolation is there, so the output generated is also fluctuating. And imagine you are in summer season, you are using a DC device which is directly getting supply from the panel, then the fan will fluctuate. Sometimes it will move fast, sometimes it will slow, and it will irritate you. So this fluctuating DC supply cannot be used directly, so it has to be stored somewhere. Where it has to be stored? We have a storage device called battery. Okay, and battery at present is not an cheap item. It is a very costly and require maintenance also. And the lead acid battery is being generally used, okay, which in fact depletes after 3 years. And generally company provide a 3-year warranty only. So battery cost is also involved, charge controller cost also involved. So this standalone system, in fact, if you go for a 1 kilowatt standalone system, it will make cost of near about 1 to 1.5 lakh rupees. While the same 1 kilowatt, the another type of system which I will talk, grid tied system, it is between 40 to 45,000 only. So the standalone system is no doubt a costly system, but it can be used where there is no availability of electricity is there. There is no grid is there, like in many dhanis, many interior villages. There we can go for standalone system. Many tribal areas also. Then another come the hybrid system. In the hybrid system, what we happens that we have a not only a solar photovoltaic system, but it is being connected with other source of devices like diesel generator set or wind energy. So that is called a hybrid system. And the third one, which is being widely used in our country and other countries also, that is the grid connected system, where the whatever the supply is being generated by solar, it is being converted into AC, because solar generate DC, and then this AC generated through inverter is being connected to our grid system via transformer. Okay, so this is being widely used, and in our own institute, that is College of Technology Engineering, at 10 location we have a 545 kilowatt of total solar grid connected plant, that is more than half megawatt. And in another campus, which is situated 5 kilometers far away from this, there we have a 500 kilowatt solar photovoltaic plant. So let's have a some look towards how they look like. So this is the picture of a standalone system. You can see solar relay is there. This is the charge controller. The charge controller is giving output to a battery. So solar is generating DC, fluctuating DC, supplying to the charge controller. As the name suggests, it will control and will provide this control output to the DC battery. Now battery output can be taken and can be fed to the inverter, and then inverter will convert into AC, and therefore we can run all our devices like tube light, TV, radio, computer, refrigerator, fan, pump, and anything like this. But here you can think a controller is being involved. Okay, a battery is being involved, so all these two increases the cost, and thereby such as an individual, no one will recommend that you go for a standalone system. Another is uh, this is the installed node PV system, a water pumping system which is generally being installed in our rural villages. Then hybrid PV system, where I have already told you that there are other devices. It can be a diesel generator set, it can be a bio generator set, it can be a wind turbine. So it is being connected in with the solar photovoltaic plant, and there we have a hybrid PV system. For example, a wind is in this picture you can see a 10 kilowatt wind plant is there. Then on the rooftop of the house there is a solar photovoltaic plant is there. So both are mixing their energy, and thereby the feeding it to the house or any farmland or like this. So this is called hybrid PV system. And the third and the last one is that is the more important, the grid connected solar pump system. And I have also uploaded my two YouTube videos. I have given in the chat box also these two YouTube videos. Okay, and this is the grid connected system. Solar panel output is directly being fed to the inverter. No battery, no charge controller is there, and thereby it is being fed to the grid. From the grid it is coming to the home also, and the extra material is going to the grid, where grid can supply to the other customers who are in need of it. And this type of system is grid tie system. Now it is well protected system. As the grid supply will go off, this solar panel, no doubt it will be generating, but it will be disconnected from the grid for the protection purpose. Because if grid supplies go, then if somebody start working on the grid and if solar is on, then it may harm the person, it can burn the person, it can damage the person. So a type of sensor is there in this inverter. As soon as the supply goes off, the solar panel get cut off from the grid supply. Now, in addition to this, all this system solar panels, we have a balance of system also. So you should know about this technical term. What are the balance? The structure for mounting the PV array or modules, then the power conditioning equipment that messages and convert the DC into proper form, that is the inverter, and the battery is being required for storing the electricity, and the other devices like controller and all these are come under the balance of system. Now, how to design a PV off-grid system? Okay, so just a few steps are there, okay, which you should know it. Collect some data. So in during our practical classes, we will go for some this design exercise also. But as far as at present in the theoretical class, I will just give some steps how to design a off-grid standalone system. Okay, so we have to collect some data. For example, the latitude of the location and solar irradiations. Then we have to calculate the solar energy, total solar energy. Then we have to estimate the required electric energy on a monthly or weekly basis. Okay, so how much energy is required? Then we will calculate the size using the data from the worst. We will also add the backup period, because in an off-grid system, sometimes the cloudy season is there. Then we may require that during cloudy season there will be no solar radiations. Okay, so we require that our clouds will remain for 2 or 3 days. So backup period is also being added, and according to that backup period, the storage capacity of the battery is being decided, and then we will install the standalone PV system. And to design a grid connected system, okay, so in a grid connected system, it is not that you may have acres of land of rooftop, so you can install any amount of grid connected PV system. No, it is not there. ऐसा नहीं है कि आपके पास आप बहुत बड़े व्यक्ति है, आपके पास एकड़ों जमीन का रूफटॉप है, बंगला है बहुत बड़ा है, तो आप पूरे बंगले पर आप अपना सोलर पीवी लगा, ऐसा नहीं है। ग्रिड सिस्टम में उसमें एक लिमिटेशन है। हमें देखना पड़ेगा कि हमारा लोड कितना है, और ये लोड हमें कैसे मालूम पड़ा, हमारा कंजप्शन कितना है, और ये हमें जनरली मिलता है हमारे इलेक्ट्रिसिटी बिल से। जो हमारा इलेक्ट्रिसिटी बिल है, हम उसको चेक करेंगे कि हम कितना कंजप्शन पर मंथ कंज्यूम कर रहे हैं, और उसके आधार पर उसको 30 या 31 से डिवाइड करके हम पर डे का कंजप्शन पता कर सकते हैं। राजस्थान के कुछ शहरों में 2 महीने का बिल आता है, तो हम उसको 2 से डिवाइड करके 1 मंथ का निकाल देंगे, और फिर 1 मंथ को 30 या 31 से डिवाइड करके 1 दिन का यूनिट जनरेट कर लेंगे। इस प्रकार हम हर मंथ का निकाल कर हम एक एवरेज पता कर लेंगे कि हमारा पर डे कंजप्शन 10 यूनिट से या 5 यूनिट से 6 यूनिट से। उसके बाद अगर हम बैटरी यूज करें, बट तो उसके लिए हमें उस बैटरी की साइज निकालनी पड़ेगी, बट दैट इज अ कॉस्टली आइटम। सो इंस्टेड वी जनरली गो फॉर अ ग्रिड सिस्टम, grid tied system. So in grid tied system, we calculate, first of all, we calculate the daily load. So daily load is being calculated. How it is being calculated? Okay, by observing your electricity bill, which is being provided by distribution authority. So you just find out how many units are being consumed per month, divided by 30 or 30 month. Okay, you will get the per day consumption. Okay, and in this way you calculate per day consumption of each month. You take the bills of last 12 months, and then you can get an average per unit consumption. From that average per unit consumption of unit, now you can decide that how much electricity is needed per unit. So from that basis you can find out the that I require, suppose there is, you require 2 units. Suppose say you require 2 units. 2 units means 2 kilowatt hour. 2 kilowatt hour means 2 kilowatt power is being running for 1 hour. Okay, so you can go for either 1 kilowatt hour which runs for 4 hours. Okay, if it is your 10 units, 10 units means 10 kilowatt hour. So accordingly you have to decide how much uh, wattage of the solar PV you have to install according to the load, on the daily basis load, not on the 12-month basis load. Just as I told you that how to calculate it, it is not only week but daily, it is to calculate AC loads. There's another method that you just identify how many loads are there, AC loads are there in your house. Okay, you calculate the wattage of each loads and how much you are consuming per day or per week. Week wise you can also calculate. Then you have to multiply by hours per week to get watt hours, and 1 kilowatt hour is equal to 1 unit. So you have to convert into that units, and accordingly you can estimate that how much units of power plant, how much kilowatt of the power plant you have to install. Then if you are using a standalone system, you have to go for determining the battery ratings. Okay, so that will give you the complete exercise in our theoretical class. So I'm skipping this point, that how to determine the PV panels and all this. Okay, but keep in mind that we have to find out by examining our load requirement. Then wiring cost is also being involved. Inverter cost is being, inverter is just meant for to convert the DC into AC. Okay, So I'm not going toward the designing process, because designing process will take in our practical class. So in the last, we can say that we have a solar photovoltaic system of different technology, of different materials, which can be operated in either in standalone form, or it can be operated in grid connected form, or in a hybrid form. And why we are using, because it is free, clean and non-polluting. It is renewable. Whatever you are getting today at 10 a.m., tomorrow you will get the same amount if the weather condition remains same. It is a sustainable energy, even it is never get lost. Okay. Then they do not produce any type of noise. Okay. And they are completely silent, in fact say. Then it can provide electricity to the remote places, like in the tribal areas or in the dhanis villages like this. The high power to weight ratio is there. They are of just 15 kg weight. Then maintenance less, very best maintenance required, either fortnightly or monthly maintenance is required. Okay. And that is also just washing of the panels. Then this source can last for longer, long life period of the solar panels. In fact, the every manufacturer provide a lifespan of 25 to 30 years. Then there are no fuel cost or fuel supply problems are there. So these all advantage, in fact, provoke us to go for solar photovoltaic system. But some disadvantage is also there. Okay. That in night time, the solar cannot help us. Okay. Then the solar panels are, in fact, still not in the approach of the common person. Even if people of, if it is in the range of 40 to 45,000 for 1 kilowatt, people still hesitate in installing it. People are waiting that when it will become 10,000 or 5,000 rupees. Then uh, batteries are required, which is also a costly item. Okay. Then reliability depend upon location also. We are fortunate enough that we are in Rajasthan, where we have a 330, more than 330 days sunny days. But in fact, like in many places like in Uttar Pradesh or in Uttarakhand, where now at present we have a so-called the fog situation. So no sunlight is there for even 10 to 15 days. So there we are devoid of the solar light, and therefore we have to think for an alternative energy source. Then one important point is that these PV cell, no doubt, on one hand we are saying that the solar photovoltaic cell are contributing in reducing the carbon emission. But if you go to a PV cell production unit, you will see a lot of carbon is being emitted in the atmosphere. So this point is deliberately being kept hidden to the common people, but they are also creating a great pollution. Then more land is required, because this is not a vertical way, it is a horizontal way of developing it is, therefore more land is required. So if you have a barren land, it is very good, as in our case Rajasthan, Jaisalmer, Badmer are the area, we have a lot of barren land is there. But where there is a highly densely populated state like Uttar Pradesh or Bihar, or there you will not find more land to install this type of solar photovoltaic. Okay. Then also solar energy is a diffuse source. It is not a permanent constant source. Now, this is the solar map of India. You can see that Rajasthan has a great potential. Rajasthan has a total capacity of 142 gigawatt. Okay, but still we are not in a position to harness fully. Still, we are very lagging behind. Okay, however, India has acquired fourth position globally in 2021, and 22 position has not been declared so far. So Rajasthan has the evidence of the solar photovoltaic energy, and we can use a lot. So thank you very much for bearing with me. But this is not the end of session, because still I have to take a slide containing 10, another PPT containing 10 slide. Okay, where I will be focusing on some advances what will happen in the solar photovoltaic technology. Okay, so just give me 1 minute. I just open my that. So after going through the fundamental of solar PV cells, solar PV technologies, I will now focus, I will give few minutes on what are the advances in solar PV technology. Is the things are over? We have developed panels of monocrystalline, polycrystalline, or even thin film cells. Now things are over. No, still there are great chances are there, and people are going developing new innovative ideas to enhance its efficiency. So what are they? So for my audience, I am just running these slides. That first focus is on the solar efficiency. As I have told you that the maximum solar efficiency which can be available from monocrystalline poly is 20%. Okay, so further the we are not able to produce the system where we have a solar tracking system in a cheap way. If we provide a solar tracking system, okay, then it will be a very costly item. So the main focus is on the solar energy efficiency and also solar tracking system. So what we are doing in this, another focus in on the solar storage. Okay, so can we have such battery where we can store energy for more than 10 to 20 days? Okay, and even you will surprise to know that when I say efficiency of 20%, mind one important point I want to elaborate. When I say efficiency of 20%, what does this mean? A panel is having 20% efficiency. It means if 100 radiations are falling on the solar panel, out of which only 20 are being converted into electricity. So where are going the 80 radiations? The 80 radiations are going waste in the form of heat. Okay, so some Australian scientists and some American scientists have focused on this 80% heat, and they have stored in a device called by a thermoelectric generator. So the heat is being liberated. They are being stored in the thermoelectric generator, and this thermoelectric generator is being used to generate electricity at night. So this much has been done in the solar storage form, that the heat energy is being captured. Another milestone in this period was done in the form of new materials. So as I've already told you that we have to go for a material which can provide an efficiency up to 40%. Okay, so recently a breakthrough was made in June 2022, where Princeton University has developed the first commercial viable perovskite solar cell, okay, which can be manufactured at room temperature and requires also less energy in comparison to the silicon based solar cell, and the production cost is also very less, and the expectancy of this type of new material is 30 years rather than 25 years for the solar silicon cell. Okay, so what is this perovskite? These are the special materials being discovered by the Russian scientists whose name was perovskite only, and and he has obtained it from a composition of calcium titanate. So basically this is a calcium titanate is there, a composite material is there. Okay, and it has a crystal structure like calcium titanate only. That is why it is being termed as it is a material composition of calcium titanate only. Okay, so this material has a very good efficiency between 25 to 30%, and it can last long for 30 years. So this material can revolutionize the whole solar industry. If still it is not commercially available, but once it has made entry into the commercial world and made successful journey in the very first year, then definitely it will supersede the silicon technology. Uh, as I've already told you that the research is also going on that how a solar cell efficiency can be improved. So recently NRIL, that is USA National Renewable Energy Laboratory, at a lab level developed a solar cell which has an efficiency of 39.5% under natural light condition, and this was published in a journal called Joule, where they have demonstrated how they have reached to this record breaking efficiency. So a new material has also been developed. and they are also being able to reach an efficiency of approximately 40% for an solar cell. So these are the two latest achievements in 2022, which can revolutionize the whole solar photovoltaic technology. Then another process is going on, the innovative designs. In the innovative designs, we have a name of printable solar cell. Okay, so these printable solar cell, they can be, they can, in fact, by the name it is clear that you can print the solar cell by putting in a machine some solution, and you will get a printable solar cell. They can be pasted on a plastic platform and they can be used on it. So this can revolutionize the this whole solar technology world. Now another is solar singles. So what people are doing, people scientists are doing, that they are developing the tiles of the shape of the solar. So the whole house can be built by this tiles only. So these are called solar singles. Okay, and they are of some roofing material like asphalt shingles or slate on which the solar PV are being mounted, and thus they can be used in the form of tiles also. Another which has become popular in India is bifacial solar PV. Okay, on both side we are having the solar cells, on front side as well as back side. No doubt you will say that the back side is not facing the solar radiations, but it is getting the diffuse solar radiations. Okay, and that diffuse solar radiation can also generate electricity, and we are combining it and thereby increasing the efficiency from 25 to 30%. So through this bifacial solar PV, we are enhancing the efficiency, and these are being now very common in India. Another concept of advancement is there of the solar window. So a solar window is basically a transparent solar cell. So far, the solar cell which we are using is not transparent, but the scientists have developed a transparent solar cell also. Okay, so we can get light also, and we can generate the electricity also. So both things can be obtained from this transparent solar cells. So this will give a concept of solar windows. Then we are going for the solar powered cars also, where we can develop like this type of solar structure, and therefore we can power our car. We need not have to depend upon the fossil fuels. Another is the sun tracking solar cells. So in 2016, the New South Wales scientists have developed an solar cell which can track automatically according to the direction of the sun, that is from east to west throughout the day. But still it has not been commercialized. At lab level they have demonstrated it. Yes, we have developed a solar cell which will sense the direction of the sun, and accordingly they will move it. Okay, but this is at the research level only. Now, this is the photograph of printable solar cell. I have already told you that a machine has been developed in which you will pour the liquid, and they will print out the solar cell, and that can be pasted on any panels. Though the efficiency is less, but for smaller work, they can be easily used. Now, these are all the advancement regarding storage, regarding the new solar cell, how to improve its cell, the innovative ways and everything. What is the status of solar energy in India presently? This is very important. So you will surprised to know that India has started a solar mission, Nehru solar mission in 2010, where previously it was aimed at up to 2020, we will have 40 gigawatt of solar energy installed throughout the India. But in 2014 it has been revised, and now we have a target of 175 gigawatt of renewable, out of which 100 gigawatt will be through solar power plant, and uh, 60 gigawatt through large scale and 40 gigawatt through rooftop plants by year 2022. 2022 has gone, and so far what we have reached only 61.97 gigawatt. So we have lacking by 40 gigawatt. So it is expected in the coming 2 years, 23 and 24, we will reach to the target which we have kept for 2022. Further, you will surprised to know that the majority of the renewable energy capacity, in fact up to 50%, my data are somewhat old, but I have checked today only that 50% of the renewable capacity is from the solar only. Okay, so I will give you in my next slide what is the present data. Okay, The present data is that in India there is a 4,09,160 megawatt of electric installed capacity is there, out of which 1,19,512 is through renewables. Now this renewable includes small hydropower plant, this includes the solar also, this includes the wind also. Okay, so and this includes the nuclear also, out of which the solar energy share out of the total electric installed capacity is near about 61,966 megawatt, which is 15.14% of the total installed capacity. And this 15% is 50% of what the total renewable energy share. And this data is obtained from Central Electricity Authority, Government of India. So I have taken too much time. My main basic aim was to give you some fundamental details about the solar photovoltaic, and also what advances is going on in solar PV technology, and what is the recent status of India regarding the solar photovoltaic or solar energy point of view. I hope you have enjoyed it. And if any question, we can take this question and discuss it. Yes, any question?